Hello students, we have discussed in our previous video that we will be having 6-day 6 video package of Python. So in this series, this is the first one. We have numbered the videos, and as per that number we are starting our journey of Python learning. So the today's topic is actually flow of control. But before starting flow of control, we have to explain basic fundamentals of Python also. So the basic fundamental of Pythons in a quick recap view. First, like all languages, Python have keywords. And like all languages, keywords are reserved words. Like all languages, it cannot be used as identifier. But there is a difference. There is slight difference. What is that difference? In all languages, keywords are in lowercase. But in Python, the keywords are in lowercase, but some keywords starts with a uppercase like true, T, false, F, none, N, and so on. The second thing is our identifier. Like all other languages, identifiers are the name that identifies a particular block in the memory. Okay. So I think that we should see some pictorial representation of RAM and learn what this identifier basically is. Like any other language, Python also works on blocks of memory, and in Python, these blocks of memory are being identified by identifier. Now, say for example, if I have a variable A, an identifier A, it points to a memory block, and that memory block is being identified by an identifier, and that identifier has a name, has an address, has a value. Okay, this identifier name, if I use the name, as you can see in your screen, if I use the name, it gives the value, and if I use the function ID with the identifier, it gives the address. Here in Python, we don't use the word address, we use the word identifier, identity. So whenever I use ID, I am actually getting the address of that particular memory block. Okay. So one thing very important, different in Python as compared to other language. In all the languages, we say that A is equal to B, and that means that both are equal. But in Python, there are two different things. One is A is equal to B, that you can see on your screen, and one is A is B. And what the difference between them? The difference between them is that if I say A is B, that means both the identifier A and B are pointing to the same memory block. So the ID and the value of A and B will be the same. So identifier in Python is basically have two things to be understood. One is the address, that is known as the ID. The second is the value, that is known as the value. Like any other language, we say the word L value as I am writing on the screen, and we use the word R value, and this unofficially L value stands for location value and R value stands for the read value, and L value is the address and the R value is the value. The same thing, but one thing is different, and that thing is the ID of the two variable, if are same, then their value is same, and this is known as A is B. On the other hand, if both the variable have the same value, but their identifier, their identity is not same, then that is known as equal to. So in Python, we generally use the word A is B and A is equal to B. If I say A is B, that means I basically mean to say that both the identifier pointing to the same memory block. Since they are pointing to the same memory block, that means their values are of course same and their location is same. But if I say A is equal to B, that's a different thing. What is the different? Difference is that A and B are having the same value, but that may not be on the same memory block. Point to be noted, that may not be on the same memory block, that may be on the different memory blocks. It may happen that, but if you will find that when you actually execute the program on your computers, you will find that if both the variable have the same value, most of the time the Python IDE gives it's the same location. Okay, it's practically the same, but theoretically it's not always same. Means I mean to say that A is B means A is equal to B, but A is equal to B does not always means that A is B. Okay, but you will find that there are situations where they will be same. It is not due to the language, it is due to the IDE that is implementing in this order. Okay, now since we have discussed the identifier, we have discussed the keywords, I think that we should have a slight view of the operators, and after operator we will straightforward move towards the flow of control. Operators are of varieties in Python. Of varieties in Python. If I say that, you can see that in C, then after C++, then after Java, a single operator was skipped. And that operator was what? That operator was exponential operator. That was an exponential operator that was skipped. But in Python, we have a different operator also for exponential. So if I am talking about an arithmetic operator, then in arithmetic operator, I have plus, I have minus, I have into, and I have divide. Now, divide is not the same like any other language. There is various subcategories of divide. So you can see on my screen that if I write a single divide sign by B, that means that it's basically a fractional division operator. On the other hand, if I am using a double slash, that means it is an integer division operator. And if I am using a percentage, that means that it is a remainder division operator. Now, let's see this with an example. You please look into the screen and you will find that if I have a 10 divided by 4, that simply means divide 10 by 4 and what you are getting is 2.5, that is the fraction value. But if I use 10 divide that is double slash with 4, it simply means ignore the fraction value, go to the integer value and you are getting 2. On the third occasion, if I am using 10% 4, what is this? If I am using 10% 4, that means the remainder. That means the remainder. We all know that if I divide 10 by 4, what I am getting? I am getting 2 as a remainder. You can easily visualize this concept in your screen that I am dividing 10 with 4. 4 to the 8, the remainder is 2, that is this 2 is the remainder. So there are 3 varieties of division. There is one variety of star, that is 1 star is for multiplication, that is 2 into 3 is 6, and the second star is for exponential operator, that is 2 star star 3, that means 2 to the power 3, that means 8. So there are 2 varieties of multiplication operator. One is your straightforward multiplication and the other one is your exponential multiplication. Now, after this we have a second category of operator, that is the logical operator. Okay, what is a logical operator basically? A logical operator is an operator that basically gives the result in the form of true and false. So here we have 3 types of logical operators and all these operators follow the English name, that is AND, and, or, and, not. Let's see how it's work. If I have a condition 1 and condition 2. If both the conditions are true, and will give you the true value. Let's see this. This true T is capital, as I have discussed in the initial part of this video, that in Python some keywords are in uppercase, starting with an uppercase. In the same manner, the true starts with T capital. And in the same manner, an or is also there. So if I have condition 1 or condition 2, what does this mean? This means that if both the conditions are true or either of the conditions are true, the result that I am expecting is a true value, and in the case of both the false value, I am getting the false value. So please be very specific about the and or. Don't get confused about and or. And I think that if you think in a manner that if I say Ram and Syam, what does this mean? This means that I am talking about both. So it's a logical and. If I say Ram or Syam, what does this mean? This means either I am talking about Ram or I am talking about Syam or I am talking about both. So this should be kept in mind. The third one is the easiest one, and that is the not operator. Not means the negate. So if I have A greater than B and simply I write not here, A greater than B and simply I have written not here. What does this mean? The negate. What is the negate? A greater than B, it's not A greater than B. It can be anything. It can be less than B or it can be equal to B. So if I write 5 greater than 2 and if I write not here, what I am expecting? 5 greater than 2, that is the answer is true, and the application of not will make it a false. So it will basically negate the value of the expression. It will basically negate what was the expected value of expression by applying the not, and we will get the not of the same. Okay? Now, the third operator type I basically want to introduce is your relational operator or conditional operator. What is a relational operator? As the name says, relational. What is relational? Relational means if I compare two values, and at the time of comparison of two values, we can get either a true part or a false part. For example, the first operator is A greater than B. So it can either be true or it can either be false. That means if I say 5 greater than 2, I will get a true value, or if it is 2 less than 5, I can get a true value, or if it is 5 less than 2, it will get a false value. So this operator is basically the comparison operator between two operands. See, we can have A is greater than or equal to B also. Please remember this. We cannot write A is greater than B in this manner. We cannot write in this manner because there is no any key to input this sign. So whenever I have to write in any language, including Python, what I have to do? I have to write A greater than or equal to B. That simply means A is greater than B. If, then I will get a true value. If not, I will get a false value. Now, in the same manner, there are equal to operators also. So the equal to operator is what? The equal to operator is A is equal to B. What does this mean? This means that the value of A and the value of B are equal. If equal, true is expected. If not equal, false is accepted. In the same manner, if I say A not equal to B, what does this mean? This means that if A is not equal to B, the value that I am expecting is the true one. And if it is not that, the value that I am expecting is the false one. So it's a clear fact that we have two equal to operators, one for equality and one for not equality. Now the next set of operator is your assignment operator, and please don't be confused with the assignment operator with the equal to operator. Huh? Say if I say A is equal to B, this A is equal to B is your what? Is your comparison operator. But if I say A is equal to B, this is your assignment operator, and assignment operator is what? Assignment operator is basically an operator that gives the value of or assigns the value of B to A. Therefore, it is known as an assignment operator. There are a set of assignment operators available in Python. What are those? Say, if I say A plus equal to B, what does this mean? This means A is equal to A plus B. If I say A minus equal to B, what does this mean? A is equal to A minus B. If I have A divide equal to B, what does this mean? A is equal to A divided by B. If I have A star equal to B, what does this mean? A is equal to A star B. So this is basically a set of assignment operators. So the next operator is our membership operator, a very interesting operator. See, Python has make the things easier, and therefore in the earlier video, the first video, I have given you a statement that Python is an easy language. It's an easy language. It is easy language, and it's a language for the beginners. So it has made the things easier. For example, see to your screen that if I write S is equal to, and there is a string, say the string is computer, okay, and I want to check that whether a particular character is in this string or not. That is, if I write M in S, what I am getting? A true value, because M is there in computer. If I say P in S, P is there in S, so I am getting a true value. But if I write Z in S, what I am getting? A false value, because Z is not there. Okay, so this is known as membership operator, and we have two types of membership operator. First is not in, and second first is in, and the second is not in. So these are two, and not in and in is just a negate one. They are doing the same thing. Now, as I have promised you all, the first thing that I will introduce today is your flow of control. So without wasting the time, starting the flow of control. See, basically there are three types of flow of controls. Okay, the first flow of control is your sequential flow of control. It is the default flow of control. It is a flow of control which we don't have to do anything. It is by default. Means the statement 1, then the statement 2, then the statement 3, then the statement 4, then the statement 5, then the statement 6, then the statement 7, and so on. So we don't have to study sequential, we don't have to learn sequential, it is by default. What I have to learn, what I have to study is our first flow of control, that is the conditional flow of control. Conditional flow of control generally is known as the if statement, and in Python there are 4 basic categories of if statements. So let's start that. So the first category is if, and here we write the condition. Here we write the condition. There is a colon. Remember that all the compound statements in Python must have a colon at the end. A colon at the end of the statement is an indicator that it is a compound statement, and there are set of statements following that. So it is our compound statement. So if for example A is greater than B, so and if I want to print, say print A, I can do the same. Okay, now this is our first category. Remember that in this category I am not using the else part, the false part. It is only the true part. The second category is your if else. In if else, what is happening? We have two paths. One path is for the true side and other part is for the false side. The true side is if I write if condition, then say I am writing A, and else, then print B. So this is if else. If else have the true part and the false part. The if part is the true part and else part is the false part. What does this mean? This means that if the if part runs with a valid true one, then this true block will be executed, and if it runs on a false part, then the else part will be executed. It's just like your C++ Java that you have studied. The third one is your if else if ladder that you have studied, I think that in C++, Java also. But here there is a slight difference. Instead of writing else if, we write elif. So the entire hierarchy will be like this. If, then we have a condition, then the statement that we wish to execute, then elif, then a condition, then the statement that to be executed, then elif, then a condition, then a statement that is to be executed, then the last one is the else one, and then the set of statements. Please remember that the else is the optional one. That means that it is not compulsorily to have an else of every if elif ladder. Okay. One more thing, never ever to use a condition with else. What happens now? We sometimes unknowingly write a condition in else. We will not provide the condition in else because the else part is itself a false part. So if the true part does not get executed, means if it gets executed as a false, then it's understood that the else part will be executed because there is only two parts. Either you can go for the true part or you can go for the false part. So without wasting any energy, you please keep in your mind that no condition with else. If however you require a condition with else, what to do? You will use an elif, or you can go for else and nested if also, but not with else alone. One more thing, Python is basically a language which does not have any braces sort of thing. Braces means I think that you all know. However, I am writing it on your screen. This is your parenthesis, this is your square bracket, and this is the braces. These all are there in Python, but they are not being used as a delimiter of the block. They are not being used as a delimiter of the block. They are not being used at that. So there is nothing like any block starting point symbol and a block ending point symbol. There is nothing like that. There is only a indentation mark, a colon mark, and that colon mark is actually acting as the control statement, control block for the starting and the ending point. So I actually mean to clear that if someone write if and someone write a condition here and a colon here, then this area is basically the true part. This area is basically the true part, and this area is neither the true part nor the false part. That means that this area will be executed irrespective of the fact that the if part is being executed or not executed. That means this part will be executed whether the if part is executed or not executed. Okay, so this is the outside. This is outside of if else. This is outside of the control block. It is in the main part. One important thing is that all the conditional, all the compound statement, as soon as we come out of the statement, we are out of the block. So everything that we write outside of that control block will be treated as the not being treated as a part of the compound statement. Okay. Now that is the fourth one, and the fourth one is the nested if. What is a nested if? A nested if is simply, nested means something within something. So nested is if within if. So there is if, there is a condition. Within that, there is another if. Within that, there can be another if, and so on. This is known as your nested if. Nested if is slight tricky. In the coming videos, I will try to make you work on those tricks of nested ifs. But for now, since we are doing the introductory part of this flow of control, so I am basically concentrating on the syntax part only. But as soon as we will move towards the implementation part, we will definitely go through these programs to show a glimpse of how they are working. One thing you must keep in your mind, that in order to develop better understanding of the if statement, you have to have a better understanding of the nested if. So this is our nested if. So if I want to have the else part, the first else part will be of this one, the second else part will be of this one, and the third else part will be of this one. Okay, one more thing, we can have a if, we can have another if here, we can have a else part, we can have a else here, we can have a nested if here, we can have a nested if here, and so on. And there is no any degree of nesting. Please remember, there is no any degree of nesting. We can have if within if, we can have if within if within if, we can have if within if within if within if within dot 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 dot. So there is no any physical limitation on the nesting. However, that after certain distance of nesting, the problem creates, and therefore it is not advisable to have a very deep nesting, but somehow nesting is fine. Okay. Now let's move on to looping structure. A looping structure is what? Please see the screen. It will have a condition, and till the time this condition is true, the block of statement will execute it. It will execute unless this condition becomes false. So we have basically two types of loops. One is our while loop and the other is our for loop. In a while loop, if I write while and if I write condition, and this is the statement, all this statement will be executed. It will fail execution as soon as it becomes false. So till the time it is true, the blocks will be executed n times, means almost infinite times, till the condition is false. In the same manner, we have a for loop also. A for loop is like that: for I in range. This is our starting point, this is our ending point, and this is the number of jumps. See, I think that this point need to be more specifically being defined. This is your initialization. So if I compare this with your old language C, C++, Java, what I am actually writing is for I is equal to 1, this part, then a semicolon, then this part I less than 10, okay, and then this part I plus plus, the same thing. So I think that if you compare with your previously learned languages, then the Python is quite easy to learn, quite easy, quite simple, and quite understanding to learn. Now there are certain things, few minor details that need to be cleared. The first detail is the range function has three parts, that is the initialization part, the condition part, and the update part. The initial default value of this part is 0. The initial default value of this part is +1. So if anyone writes a range 10, that means it will start with 0, it will go till 9. Remember, 9. So if I write n, I will go till n minus 1. If I write 10, I will go till 9. If I write 20, I will go to 19. So if you want to have a 20, you write straightforward 21. If you want to have 100, don't write 100. You write 101. writing 101 makes it 100. Then 0, then your last 9, and then your plus 1. So it would be like this: 0, 1, 2, 3, 4, so on till 9. So this is basically the for loop. The same logic here also, as we know in the C++ Java, that while is basically used when we are not basically knowing the number of iteration, that is the starting and the ending point, but we are running the loop until this condition is true, until this condition is false. If this is in our mind, then the while loop is perfect. But if I have a more greater visualization, that is I have to start with 1 till 10, that is I know the initial value, I know the final value. I have to start with 1 and I have to go till 100. If I know the lower limit, I know the upper limit, then we will have to use the for loop. It's not that we can't do it with the while loop, we can do with the while loop also, but the for loop is a better choice when the starting and the ending point is fixed, and the while loop is a better choice when the starting and the ending point is not fixed. Okay, so I think that this is a informative video on the flow of control. On the next video we will meet definitely with the second topic. One more thing, you please have practice on the different type of looping programs. I will have a different video, not in this series, a different series, explaining some popular programs, execution and popular program writing skill, so that you can know the language and you can use the language. Thanks for listening, viewing the video. Thank you.